Good morning, everyone. Distinguished delegates present on the occasion, my colleagues and engineers from WBPDCL and all the participating organizations. I hope that you are doing fine in this pandemic situation, and we'll try to make this Sunday a little fun day for you, and you are locked in from your distinguished from respective houses or from your office. Engineers Welfare Forum, WBPDCL, have organized this webinar on a very pertinent topic, a topic that has become a hot cake in the thermal power sector. That's latest technological advancement in ash handling plant of coal-fired thermal power station organized by Engineers Welfare Forum, WBP DCL SGTPP, powered by Enviro Level Controls Private Limited. Environment is the surrounding in which we live in. It is the source of life. Our whole life is dependent on the environment. It directs our life and determines our proper growth and development. Good or bad, quality of social life depends on the quality of our natural environment. The Paris Agreement signed on 2016 called for a balance of climate finance between adaptation and mitigation, and specifically underscoring the need to increase adaptation support for parties most valuable to the effects of climate change, including least developed countries and small island developing states. This seminar hopefully will throw light on overcoming the challenges faced by us during day-to-day operation, maintenance and disposal of ash in out thermal power stations, and make us aware of the latest technological advancement in ash handling plant of coal-fired thermal power plants. I again extend my warm wishes to the participants, sponsors, and the learned speakers who will make deliberations in this webinar. The latest technological advancement in ash handling plant of coal fire thermal power station organized by Engineers Welfare Forum, WBP DCL SGTPP, powered by Enviro Level Controls Private Limited. And in this lovely occasion, we have got our respective speakers in this panel. I'd like to introduce one by one here, and they will be showing some light on this topic, and definitely will be having some lovely gala time in these 2 hours. First, I'd like to introduce Dr. Abhishek Goyal, Enviro Level Controls Private Limited. Welcome, sir, on board. Next, I would like to introduce Mr. Rajat Goyal from Enviro Level Controls Private Limited. Welcome, sir. Next, I'd like to introduce Mr. Raman Lamba, Executive Director, Macabre BK Private Limited. Welcome, sir, on board. Next, I'd like to introduce Dr. Ss Malik, Associate Professor, Thapar Institute of Engineering and Technology. Welcome, sir. And in this lovely occasion, I've already told about all the things that we are going to put up some light on. But before starting this event or starting this webinar, we'll be seeing a video on this topic of Engineers Welfare Forum, WBPDCL. Let's have a look on the screen.
Engineers Welfare Forum, an ISO 9001-2015 organization registered under West Bengal Society Registration Act 1961, is a premier consortium of engineers of the West Bengal Power Development Corporation Limited, the chief power generating company of the West Bengal, formed on 25th October 2010 by a visionary group of engineers of the WBPDCL. EWF, from the very first day of its inception, has dedicated itself in achieving collective welfare of the engineering fraternity. It operates through its local bodies based in Sagardighi Thermal Power Project, Santaldi Thermal Power Station, Bokreshwar Thermal Power Project, Kolaghat Thermal Power Station, Bandel Thermal Power Station, and the WBPDCL Corporate Office at Kolkata. EWF has time and again come up with practical and relevant training courses for its engineers in the areas of vibration analysis and balancing, coal characteristic and sampling, NDT boiler tube metallurgy, power transformers operation and maintenance, availability based tariff, GST, and also in regular software domains like Advanced Excel, AutoCAD, MS Project, etc. Prayas, the flagship social event of the EWF, is an effort through which a total of 500 underprivileged but meritorious school students residing around WBPDCL's power stations are felicitated every year with school bags and year-long supply of study kits. This is an initiative which also aims to nurture and fulfill the social obligations of our engineers. Further, such events help to develop a cordial relation with the underprivileged local people at various power stations. In view of the shortage of blood at different blood banks of West Bengal, EWF come forward to organize blood donation camps at the townships of Kolaghat and Santaldi thermal power stations in the year 2016. The Honorable District Magistrate of Purba Medinipur, Dr. Rashmi Kamal, IAS, and Dr. A. Datta, the Chief Medical Officer of Purulia, have graced the occasion as chief guest respectively. A sum of Rs 50,000 only has been also donated to the Chief Minister's Relief Fund for Nepal disaster. EWF also operates catering services at remote power stations through its self-functioning eateries. This helps engineers staying away from their families avail home quality food at reasonable prices even at distant locations. Eateries, especially the one at Santaldi Thermal Power Station, has greatly benefited the engineering community since finding food at that remote location used to be a huge ordeal before. National seminars and workshops have been organized by EWF in every year under the flagship program NEED, National Energy Excellence Drive, covering energy-related issues which may enrich the Indian power sector. So far, the following national seminars have been organized. Importance of water chemistry in thermal power plant in the year 2011, coal management for thermal power plant in the year 2013, emerging power scenario in India in the year 2014, non-conventional power scenario in India in the year 2015, and competitive economics of Indian thermal power generation in the year 2016, and one workshop, pollution control in coal-based thermal power plant in the year 2017. Each year, the seminars have witnessed the congregation of minister in charges, policymakers, scientists, and other stalwarts to deliberate on issues related to the Indian power sector. PowerGenX, the flagship technical journal published on the day of the seminar, chronicles all the findings and analysis brought forth in the colloquium. EWF also brings out a biannual bulletin named Vision to showcase the various technical breakthroughs of our engineers at their respective plants. EWF is planning to establish technical libraries at all power plants township where technical journals, books, magazines, etc. will be made available for the members. EWF is helmed by an honorary board comprising vice chancellors, scientists, and directors of reputed central universities, institutions, and organizations like IIT Kharagpur, Jadavpur University, IIEST Shivpur, IIT ISM Dhanbad, CIMFR, Geological Survey of India, BHEL, NTPC, Power Grid, and Indian Railways. This board is always available for any technical or administrative assistance that WBPDCL may require for its smooth functioning. Engineers Welfare Forum maintains a dedicated interactive website to communicate with the world. The entire gamut of EWF's activities is archived in it, as also various articles, downloadable technical journals, vendor list, blood group list of members, etc., form a part of its assorted repository. Engineers Welfare Forum has come a long way from being a nascent body of few visionaries to a collaboration of almost 700 engineers of the WBPDCL. All along, EWF has nurtured the aspirations of its young engineers who in turn have pulled out WBPDCL from stasis to growth and prosperity. Engineers Welfare Forum of the WBPDCL pledges to continue this journey with similar grit and enthusiasm in the coming years.
Thank you so much. That was a lovely video, and from this video, you have come to know about the lovely job done by EWF, not only to raise their organization but help socially towards other people and organizations. Adding towards this thing, in this last 6-7 months, we were having ups and downs. To be precise, we were having a hard time where many lives have been lost in this pandemic, where people are stepping forward, people are moving forward, people are lending their helping hand towards the frontliners, where EWF is not lagging behind. EWF has come forward and they have donated a sum of rupees 2 lakh one, and they have delivered a check to Ramakrishna Mission to help the frontliners and to fight this COVID-19. And hope that we'll be having a great time in the next couple of months. And kudos to Engineers Welfare Forum, WBPDCL, for this lovely, generous acceptance towards the society, and definitely will be having more helping hands from the organization towards the frontliners, toward our social and economical uh, stabilization of our what I can say, civilization towards our nation. Well, at this lovely moment, let's not waste any time. I will be moving towards our main topic. That's the latest technological advancement in ash handling plant of coal-fired thermal power station, organized by Engineers Welfare Forum, WBPDCL, ACTPP, powered by Enviro Level Controls Private Limited. To start this lovely session, I would like to introduce our first speakers. Rather, I'll not say speaker. We have got speakers with us here in this lovely moment, and I'd like to introduce them here in this lovely moment. First, I'd like to introduce Dr. Abhishek Goyal, a medical graduate by profession with an MBA degree, is pursuing his family business in instrumentation started by his father, Dr. Ravinder Goyal. His in-depth acquired knowledge of the subject and working on the inventory measurement of bulk solid has been commendable for the growth of EIP in the recent past. Next, I'd like to introduce Mr. Rajat Goyal, an electronic engineer with an MBA degree, joined his family business 6 years back and has contributed since then in new product development and solutions for the customer, which has raised a portfolio of offering offered by EIP. And obviously, Dr. Ravindra Goyal, an electronic engineer with a a doctorate in entrepreneurship is the brain behind EIP. His passion for innovation has the started point of the company in 1980s, and his dedication towards serving the customer with the best technology and services has given EIP the structure what it has today. Before the presentation, we have got a very important person in our in this lovely moment, and to address our panelists, to address our speakers, I'd like to introduce our very important person, Engineer Shuman Sharkar, Executive Member, CEC, Engineers Welfare Forum, WPP I'd like to uh, request Mr. Shuman Sharkar to address all the panelists, all the speakers on board. Over to you, sir.
Thank you. Good morning to everybody present here in this virtual platform with us. On behalf of Engineers Welfare Forum, I welcome you all and extend my warm regards for your presence. We 600 odd engineers at Engineers Welfare Forum are engaged in different social activities apart from our core area of interest throughout the year. We believe that protecting environment is a social responsibility of all citizens. The program we are organizing today merges two dimensions: social responsibility of a citizen with the professional obligation of a power plant engineer. Today, we have with us Honorable Dr. Abhishek Goel and Mr. Rajat Goel, both from EIP Enviro Level Controls. Mr. Raman Lamba, who is an Executive Director in Macweber BK Private Limited, and Dr. Ss Malik, Thapar Institute of Engineering and Technology. I thank you and extend my gratitude for sparing your valuable time. In this COVID age, webinar has become the new normal, and we believe it would continue for all the right reasons. Coming in today's program, let me tell you that we are very sensitive to environment. We organized a program about green energy, clean fuel, renewable energy, importance of imbibing technology to counter emission in the past years. As we all know, that the regulatory authority has come up with strict regulations towards environmental emission standards like SOx, NOx, SPM, and usage of water consumption, and fixed benchmark for different power stations. No doubt, we welcome this as it's a very good step and it's in the right direction. One major source of pollution is emission from coal-fired thermal power station. The problems are manifold, from quality of coal, logistical issues, to old design parameters adhering to previous environmental standards. And one other dimension of the problem is disposal of ash and subsequent utilization. For fly ash disposal, dry mode is preferable to avoid soil pollution, minimize land utilization, and optimize usage of water. Again, considering the diversity of Indian thermal power stations, one size does not fit all. For utilization of ash, again, there are various opportunities as well as different quality ash requirement for different application. We think that technological advancement and judicious management may be the ways to address the issue. I believe that learned persons and experts in this field with us today would enlighten us regarding these multidimensional issues and possible line of solution. Thank you all again to spend your valuable time with us. Thank you.
Thank you so much, sir. That was Engineer Shuman Sharkar, Executive Member, CEC, Engineers Welfare Forum, WPP Well, I was talking about the lovely gesture by Engineers Welfare Forum, WBP and they have handed over a check, some amount 2 lakh one to Ram Krishna Mission, and that's the receipt you will be seeing on the screen as a receipt, and definitely we'll be having more COVID-19 warriors, the frontliners, and they will be having their power in their heart to fight COVID-19 in this pandemic. Thank you so much. Thank you so much. And that's a lovely gesture by Engineers Welfare Forum, WBP DCL. Well, now coming to the main topic, as we are in the webinar, latest technological advancements in ash handling plant of coal-fired thermal power station organized by Engineers Welfare Forum, WBP DCL, SGTPP, powered by Enviro Level Controls Private Limited. And on board, we have got two people together, and they will be sharing their views. They will be putting on some light on the topic. Dr. Abhishek Goel and Mr. Rajat Goel on board. Over to you, sir.
Thank you very much, sir. Am I audible, sir?
Yes, sir. You are audible. Yeah, absolutely.
And I hope my screen is now visible, the presentation.
Yes, it's visible clearly.
Okay. So first of all, thank you very much for this brief and very good introduction. And I would like to thank, firstly, a very, very good morning to all the panelists, all the hosts and the attendees and the, because of you, this webinar is happening, and we would like to extend a gratitude towards Engineers Welfare Forum for organizing this platform. And thank you for the brief introduction about EIP and Dr. Ravinder Goel, who's our father, and Rajat Goel and myself. Thank you very much, sir. So without wasting time, we will just shift on to the topic that EIP Enviro Level Controls Private Limited is offering for today, which is basically fly ash handling and some unique solutions. So before we start the presentation, I have a brief introduction about EIP. EIP is a company that started in 1983 by Dr. Ravinder Goel, and we started with the first indigenous manufacturing of the RF level switch for ESP fly ash hoppers. We take pride in the fact that at currently almost 80% of the power plants in India are using EIP RF level switch for their ESP fly ash hoppers. Since then, we have moved on to the different product portfolio, which includes level, all the ranges of level measurement products, starting from point level measurement to complete inventory level measurement, then flow measurement, density measurement, and we have some valves. Because of in the last 3 decades, we have been focused highly towards our customers, bringing them the most advanced solutions and providing prompt services. And that has been the reason behind our success and persistence for the last 30 years. The industries we are catering to are power, cement, steel, fertilizer, chemical, petrochemicals, alumina, food, and other process industries. So basically, wherever there is a requirement for level, flow, inventory, or density, and EIP is always present with a unique solution to offer to that industry. Now we will move on to the first topic of discussion. So I'll just brief you about the structure of the presentation. So we'll be covering the presentation in form of challenges. So we'll discuss a challenge faced by the ash handling plant and what is the solution EIP has to offer for that specific challenge. So the challenge 1, we will talk about the Fg duct. I will just request Mr. Rajat to just brief about the challenges being faced in a flue gas duct. Over to you, Rajat.
Yeah, thank you, Abhishek. First of all, good morning to all, and thank you for this opportunity. This is a special application which we did in collaboration with NTPC recently. And what we observed was with NTPC that FG duct, the duct between boiler to ESP, and the plants above 500 megawatt, the velocity of ash traveling from boiler to ESP was very low when the plant was not operating on full load. So due to that, the ash was getting accumulated in the flue gas duct. And this accumulation was so much that even sagging of around 500 happened in Solapur thermal power plant of NTPC. And due to this reason, NTPC asked us for the solution, and we provided them with the solution. And we successfully provided them with a solution in 2 of their power plants, that is Lara thermal power plant and Khargone thermal power plant, and in fact in Solapur plant also. So this is the challenge what we faced of ash accumulation in flue gas duct. Abhishek, can you move to next slide?
Yeah.
So, yeah. So what happens is in FG duct is there was a lot of ash accumulation of around the total height of duct was around 7 meters. This is about the Lara thermal power plant, and the accumulated ash was more than 2 to 3 meters. And sometimes in some of the areas, this was around 4.5 meters and 5 meters also. So we gave them a good solution, and Abhishek will be able to explain more about the solution what we provided about the 3D radar for this FG duct application. Over to you, Abhishek.
Thank you, Rajat. So, sir, like Rajat already explained, what is the challenge in FG duct? There is ash accumulation when the plant is running on lower load, and there are various reasons for plant running on lower load. In fact, the upcoming scenario which says that the coal-fired power plant will be running in sync with the solar-fired power plant. So during that protocol, there is a design wherein during the day the plant coal-fired power plant load will be reduced as solar would be taking up, and during nighttime coal-fired power plant will bring up. So that will lead to the speed velocities within FG duct to be very slow and fast, varying upon the capacity and the load. So what happens when ash accumulates in a FG duct? Why is it very critical? The reason is the ash always accumulates in an uneven profile. There will be a lot of dust, and there will be maintenance issues and very high temperature to the tune of 350 degrees Celsius. So what is the solution that we offer is a 3D radar level transmitter. So there are 4 critical points in the FG duct starting from the boiler to the ESP. There are 4 critical points wherein the ash accumulates the most. Therein we will install our 3D radar level transmitter, which is the world's first multi-beam radar operating at a frequency of 140 gigahertz. What it provides is the average level of the ash accumulated within that critical point, what is the maximum level of the ash accumulated, minimum level, and the volume of ash within that critical area of the FG duct. It works in heavy dust without air purge and works at very high temperature. We have even used these radars for as high as 1200 degrees Celsius. So a temperature of 350 degrees Celsius is easily manageable. So let us now just have a look at the basically structure of a FG duct, how it looks like and what are the critical points. And there's a real-time picture of inside of the FG duct, and you can see the amount of ash being accumulated. So there's the amount of ash you can see is accumulated, and this causes the sagging of the duct because it has no support from the bottom. This is the 3D radar level transmitter being installed in this FG duct. And you can see the real-time 3D profile of the material. You can see the variability in the profile from the right side, wherein it is low height to a high end side. So you can see over here, the minimum level is 1.4 meters and the maximum level is to the tune of 2.88 meter. You can imagine a duct which has a height of 7 meters, a 2.88 elevation of ash accumulation is too high, and it puts a mechanical load on the FG duct. So this, in fact, is one of the most unique solutions we are offering for ash handling plant these days with the FG duct level measurement. Now we come to the challenge 2, which is basically fly ash silo level. So people usually ask us, why is it critical to measure fly ash level? The reason is fly ash these days is revenue. And as they say, a penny saved is a penny earned. So the inventory management of fly ash, if that can be regulated, is something that is a direct revenue to the plant, because we are selling the fly ash to cement plants and other process units. Now, again, the fly ash measurement, as for any bulk solid, is critical because fly ash always is accumulated in an uneven way. There is a lot of dust inside a fly ash silo, and there are multiple maintenance issues. And added to that is the fly ash silos almost 24-hour running. There is filling or emptying, something or the other process always going on. So you cannot miss to have a reading of inventory, and you cannot miss a shutdown being caused due to a level transmitter in a fly ash silo. So the solution again remains the 3D radar level transmitter, which I've already explained the features about. On the right side of the screen, you see how a 3D radar level transmitter would be working in a fly ash silo. It has 5 beams in different directions. using these 5 beams, I'm actually able to generate a real-time 3D profile of the material because it has XYZ coordinates of those 5 points. Joining them, we get a real-time profile of the material. So this is a real-time screenshot of a 3D radar level transmitter being installed in a fly ash silo, and you can see the profile unevenness in this silo. This is again a silo. This is not a fly ash silo per se. There's a very big clinker silo, and you can see we have 3 numbers of 3D radar level transmitters installed to generate a real-time 3D profile. As the world is currently moving towards complete 3D profile management for various activities, so we also say that why not do a complete 3D profile assessment of bulk solids and powders, because this gives you a lot of information about your inventory. And obviously you have the volume and you have the mass at hand at all times. Now let us have a look at a small video on the 3D radar level transmitter. So this is so as I said, this is at 140 gigahertz, and so you see this is a single beam measurement. You can see the kind of error you may be having because of a rat hole that is formed, something like this. Now, if you have a 3D radar level transmitter installed in the same silo, you will be having a profile which is real time in nature, and you can see on the left side the profile is generated just like what is shown on the silo. And when you do a comparison, you can achieve very high accuracies to the tune of 2 to 3% when you use a 3D radar level transmitter when compared to a single beam radar level transmitter. There's a real screenshot, real live video wherein we have a silo, and you can see, you can move the 3D profile and actually see how the material is taking shape within the Fg duct or a fly ash silo. So these are 2 sensors being installed in the same silo. You can easily imagine if I have a single beam radar, how uneven my readings would be. So now I will move on to a next unique challenge, which is very close to the heart of EIP. Why I say heart of EIP is because EIP started the business with ESP fly ash hopper level measurement. We mentioned the RF level switch, which 80% of the power plants in India are using. EIP make RF level switches, and 100% of the power plants have a mandatory requirement of a ESP ash level indicator or a RF level switch. So this topic is very close to our heart because we understand that ESP measurement, level measurement, is very critical. And why do we say it is critical? The reason is in front of us in terms of the recent accidents where we have witnessed ESPs being collapsing in well-established big power plants. Current measurement is only a switch. A switch gives a high and low level. You never know what is happening apart from that high or low level. Then other critical point is that the evacuation right now in ESP hoppers is on a timer mode, whereas it should actually be on a case-to-case basis. Whenever the hopper fills, I should evacuate that hopper. It should not be on a timer mode, because a timer mode of operation is a heavy cost that is involved in the operation to the plant. Then again, the fourth point of criticality is whatever measurement principles we are using are intrusive type. What I mean intrusive is it is installed within the ESP hopper. Anything that is installed within the ESP hopper is prone to wear and tear. The reason being, the ash has a high temperature. The fly ash in ESP hopper is high temperature. There is a lot of electrostatic charge, and plus ash has its own abrasive nature. So these all points make it very critical to have a very robust system for ESP ash hopper level measurement. Now, what is the solution? The solution is a Nogs sensor, which provides continuous level inside a ESP hopper. Yes, it is a continuous level transmitter within the ESP hopper. And how it is installed. So if you see the blue picture over here, this is the NOGS sensor, and it is installed 30 to 50 away from the aluminum cladding. So this, what you see over here, the point number 3 is the wall of the ESP. Serial number 2 is the insulation layer, and outside 5 is basically the cladding. So you see this cladding, this NOGS sensor is installed outside the cladding, which means there is no cutout, no shutdown required for installation. This is amazing because you're installing something outside the hopper, absolutely outside. Now you would be wondering, how is something able to work or make a sense of ash level inside the hopper when it is installed completely outside? So let us look at the phenomena or the principle behind it. The principle is very simple, which says that this sensor, the NOGS sensor, detects the gamma ions which are present in the fly ash. Yes, the coal fly ash is radioactive. There is a separate theory which says why coal ash is radioactive. You can just send us an email post the presentation if you want a theory or a scientific literature on that. But as of now, let us focus on the fact that my coal fly ash has radioactive particles, radioactive gamma ions, and my NOGS sensor is only detecting those gamma ions. So there is no source involved, no external source. My fly ash is radioactive, and my NOGS sensor is able to detect that gamma ions to generate a continuous level. The quantum of fly ash is proportional to the quantum of gamma ions, which is proportional to the quantum of level detected by this NOGS sensor. So this is the theory behind this NOGS sensor. So you see, this is completely non-invasive continuous level measurement. Fly ash can do absolutely no harm to this sensor. It is easy to calibrate, easy to use. It is what we say, it is like your eyes inside a ESP hopper. So you can now virtually see what is inside the ESP hopper in a continuous measurement through this NOGS sensor, and you can practically operate your evacuation mode on this NOGS sensor. So what we say is the evacuation now is running on an NOGS mode. NOGS mode is wherein this NOGS sensor gives you a feedback automatically. Yes, this hopper needs to be evacuated. This is truly and truly a cost saving benefit wherein you can realize the return on investment from day one of installation of this NOGS sensor in the fly ash hopper. So let us look at few of the installations. So you see, this is installation from one of the power plants in India, and you see this is validating the fact that this is installed outside the hopper. You just have a steel angle and it is installed outside the cladding. Just let us have a close up. So you can see it is installed outside, and you have a continuous level measurement. So right now it says it is 33.4%. So you have a continuous gradation of level inside the ESP hopper. So now let us move on to challenge 4. So challenge 4 we say is buffer hopper level measurement. Again, buffer hopper is the intermediate transit hopper wherein overfilling and underfilling are critical problems, and is something that is operating at a very fast speed. It fills up very fast, empties very fast, and it is in continuous operation. So the challenge of buffer hopper remains the same like fly ash, dust, maintenance, 24-hour active, and high temperature. And adding to that is high pressure inside a buffer hopper. So what is the solution that we offer? Because a buffer hopper is very small, maybe 3-4 meters. Going with the 3D radar technology may not be always advisable for a buffer hopper given its size. So we have this 140 gigahertz radar level transmitter being installed in the buffer hopper. Again, it is at a frequency of 140 gigahertz, and it is the world's smallest beam angle radar, which is at 2 degrees, works in heavy dust without air purge, with a very high temperature, and even can pass through a blind PTFE. So yes, this is a fact that is to be noticed. If you see this sensor in the center, which is a small sensor, this one, if you place a PTFE disc below this sensor, a blind, the rays can pass through it and get back through it. So this is the kind of accuracy with which and the power with which this radar level transmitter works. So I'll just share my screen once again because I have a video which I want to share. And I think just a second. Share computer sound. Just a second. Just a second, sir. I'm just, yeah, is the screen visible, sir? Rajat, screen is visible?
Yes, yes.
Yes, sir. Yes, sir. Screen is visible, sir. Yeah.
So this is, I wanted to show a video. Is the voice coming?
Yeah, yeah, it's coming.
Voice is coming. So,
Yes, sir.
this is an installation of this kind of a radar being installed not in a power plant, but we have installed at a temperature of 1200 degrees Celsius. And like I said, it is working in such a stringent condition. So you can see there is dust, there is fumes, there is temperature, and this radar level transmitter is giving an accuracy close to 2 to 3 within this environment. This is basically the molten metal being poured inside a vessel, and you can imagine if something is working in this stringent an environment, it is supposed to work in a buffer hopper. So this was a small video of how to show that this 140 gigahertz radar level transmitter is the most optimal device to be installed for a buffer hopper level measurement. Now we come to challenge 5, which is density measurement of wet ash slurry. So this is applicable for power plants which are having wet slurry discharge. And why is density measurement of wet ash slurry important? Because if the slurry is too dilute, there is loss of water. And if the slurry is thick, we have chances of pipe choking. These are very brief, very gross level criticalities for ash slurry measurement. And what are the current density measurement challenges being faced by the industry is the density measurement which is actually working easily are the wetted and contact type. But the problem with wetted or contact type is it does not last long in ash slurry. Ash slurry is very abrasive. It damages the sensor. It chokes the sensor. It chokes an inline density meter. So whatever technology we may ask an orifice type of flow density or a Coriolis type or a vibration type, whichever type of contact type density meter you may want to use, it does not work for long and practically of no use. The only solution that is coming to the industry as a non-contact type currently is nucleonic type. But the nucleonic type has its own problem. It has AERB restrictions. There is license for usage. You might be needing a radiation scientific officer. You need to submit every half yearly a report. And there are chances of frequent surprise inspections by AERB. And the reason behind all of this is the source being used is cesium-137, which has a radioactivity of 1.5 gigabecquerel or 20 millicuries. We will go on to the next slide to realize the importance of this 20 millicurie. But as of now, I just request you to remember this figure of 20 millicurie. So this 20 millicurie is a health hazard, and that is why AERB is putting so many restrictions. We have cases in power plants wherein the density meter has been ordered in 2015 and it is 2020. The density meter is yet not supplied. The reason AERB has still not given approvals for installing the density meter. The license has not been awarded by AERB. If you're going to use 5 density meters in a plant, you need approval for 5 of them. You need an NOC. And there are cases where the density meter is still. And who is the end use sufferer? Sufferer is the project supplier and the customer, because the project supplier, for the project supplier, the project is not getting closed, and for the end user, they are not able to get the density. And this is the reason. So what is the EIP solution for this? So we have 2 unique solutions. First is sodium 22 based non-contact nucleonic density meter. Yes, it's a nucleonic density meter, but it uses sodium 22 as a source, which is AERB exempted. And why is it AERB exempted? Because the source strength is 700 kilobecquerel or 0.020 millicurie. I'll just move on to next slide to show you this was 20 millicurie and 1.5 gigabecquerel. This is 0.020 millicurie. So it is almost 1/1000th of the strength of what is conventional. and 700 kilobecquerel is, you can compare giga and kilo. So that's the kind of difference. So there is no license requirement for procurement and usage. There is no reporting, no RSO. It is completely safe. You can even hold the source button source in your hand for 10 minutes. I will show you in the next slide what this means to hold a source in your hand. The second solution that we have is ultrasonic clamp-on slurry density meter. Yes, you have heard of ultrasonic clamp-on flow transmitter, but we have introduced an ultrasonic clamp-on slurry density meter. So it is working on the principle of a sender and receiver ultrasonic waves, wherein the attenuation of the ultrasonic waves gives an accuracy as good as a nucleonic device. So density measurement can be done as accurately as a nucleonic device. It is mounted outside the pipe. Now the question come up, which device to use? So basically this is an application problem which we request customers to generally send us the application details, like the size, diameter of the pipe, size of the pipe, the slurry, expected slurry density, and based on which we take a decision whether ultrasonic would be the best fit or a AERB exempted nucleonic density meter would be the best fit. So again, this is a solution which the industry power plant was looking for, and here we are with a solution for the measurement. So now let us just look at this density meter. So this is the source and this is the detector being installed. And what I was referring to that the sodium 22 source is as small as a button size, and you can hold it in your hand for 10 minutes. So over here, I would also like to brief you. So when we talked about nucleonic, we are talking about nucleonic density meter where there is a source and a detector. And there was a ESP ash hopper level measurement where we were again talking about only a detector but no source, because my fly ash was the source of radioactive ions. So I just want to clarify these 2 points over here, that this nucleonic density meter for slurry measurement uses a source and a detector which are exempted from AERB. Continuous level measurement for ESP hopper was using only a detector. There was no source and there is no approval, nothing required. This is the ultrasonic clamp-on density meter. The picture on the right bottom, what you see is ultrasonic clamp-on density meter. So now I would hand over, I would request Rajat to just enlighten us about the challenge 6, what we say is the walls for dry fly ash and ash slurry. Over to you, Rajat.
Yeah. Thank you, Abhishek. Yeah. So in ash slurry applications, one of the major challenges faced by the customer is transportation of ash, and generally fly ash and ash slurry. So the knife gate valves, generally conventionally installed in a ash handling plant, they generally tend to wear down due to the abrasion and corrosion of slurry. And like fly ash is a very abrasive slurry. So generally in 2 months time, conventional knife gate walls tend to wear down, and every 2 months customer has to take a shutdown and replace the seat, gate, and the body. So this is one of the challenges customer is continuously complaining to us. And generally this shutdown time is quite long because these walls are heavy and replacement takes a lot of time. So, and it's very expensive also, like in fly ash what we have experienced in like DVC plant, Durgapur. So the fly ash is being transported to one of the cement factories, and replacing valve continuously after 1 or 2 months, it's very expensive, and they have to completely stop the line and then replace the valve. And we have a special knife gate valve for such applications, and in fact we are very proud of these valves and the performance of these valves. Abhishek, can you move to the next slide? Yeah. So we have this, we are tied up with a Swiss company, Eject, who are manufacturing these special patented knife gate valves, and we are proud to be associated with them and the performance which we get with these valves in ash handling plants especially. So it's tremendous. In fact, in DVC, Durgapur, Raghunathpur, and various NTPC plants also, these are special non-clogging valves, zero leakage. It's zero leakage. What when we say zero leakage, so it's better than class 6 bubble tight shut off. So we have this bubble tight zero leakage patented design of these valves. Then we have transverse seal, mechanically retained seal. The specialty of these knife gate valves is that under full pressure, the seal can be replaced. In the next slide, we'll show a small video where you'll see how we can replace the seal in full pressure condition. These are some of the installation pictures of our knife gate valves in fly ash applications. Abhishek, can you switch to the video?
Imagine
Voice, Ari? There's voice?
Yeah, voice is coming.
a valve that doesn't leak. Guaranteed.
So the specialty of these valves is in the gate design and the body design, which is a patented design of this company, Swiss company. As you can see, the gate design is a straight gate. Conventionally, the gate design is a 180-degree arc. As you can see in this, it's a straight gate with a mechanically retained seal between the two bodies.
While in service.
Like as you can see, there's leakage during operation after a year or two. So without in full pressure condition only, we can replace the seal kit. We have to just unscrew the two nuts and we can insert the seal kit. And again, our valve is good to go.
Against emergency downtime.
This helps in reducing the shutdown time. We do not have to take the valve out and then do the replacement of seal kit. As you can see, again, in full pressure condition, the valve is good to go. We have a unique transfer seal. This is according to applications of the customer. So in ash handling plant, we have a unique transfer seal. This can be replaced in full pressure condition.
While opening or closing. Unique gate geometry. Promotes self-cleaning.
As you can see, I told you this gate is a straight arc. So automatically the design of gate helps in cleaning of valve when it closes down.
Self-cleaning without flush ports. Complies with AWWA C520-10. Reduced chest cavity. Prevents solids from jamming.
As you can see, this is automatic without flush ports. When the valve closes, automatically it cleans the valve and closes down. This is because of the special design of body and gate which they have.
With full pressure, both directions. Non-rising stem saves space. Installation in tight locations.
In fact, these valves are one of the valves which are for petrochemical industries. These are
100%
suggested by the licensor of the technologies, like DuPont and Belco. And in fact, in various Indian petrochemical plants also, these valves have been replaced.
Ongoing cost savings.
The conventional valves has been replaced by these valves. When the licensor have recommended our valves for
Plug valve,
applications.
which
In
results
fact, in NTPC plants also, various NTPC plants, by the performance feedback of various customers from other NTPC plants, they have replaced the conventional valves with our knife kit valves. Thank you. Now I hand over back to Abhishek for summarizing.
So, sir, thank you, Rajat. So, sir, we've just seen a few details of the challenges faced in FG Duct, wherein we have a solution: buffer hopper, ESP fly ash hopper, fly ash silo, density measurement of ash slurry, and the valves, knife gate valves for dry and wet fly ash. So basically, this was a small presentation where we discussed the unique challenges faced by the ash handling plant these days and the unique solutions by EIP. I hope there was some information which was useful to you. If you have any further queries, you can write to us, email to us, or call us on the below numbers. You can take a note of these numbers and you can approach us anytime. The presentation was not supposed to have more science behind the device because we were covering a lot of information in a short span of time. So if you need further technical details, science behind a device, you can again call us or write to us on the below details, email ID or the phone numbers. We would Now, from the team of EIP, we would like to thank you for your patience for this presentation and sparing your time on this busy Sunday. Busy, or I should say, a Sunday which is meant for resting. So thank you so much, and wish you all the health in this COVID scenario. And if you have any questions right now, I think the questions will be taken up at the end of the presentation. So we are available for those questions as well. Thank you so much, sir. And thank you, sir. Thank you so much.
Thank you, sir. Thank you very much.
Thank you.
Thank you so much. Thank you so much, Dr. Abhishek Goyal and Mr. Rajat Goyal, for putting up some light by your presentation. And definitely, as Dr. Goyal said, that the panelists, the participants, to be specialized, might be having some questions to our panelists. So if you want to ask any questions, the participants, the spectators, if you want to clarify your queries, if you want to ask any questions to our respective speakers, you can ask the question on the chat button. Yeah, I'll request everyone to please shoot your questions on the chat button so that it can be visible to everyone. And after completing all our presentations by our speakers, we'll be heading towards our panel discussions, where your questions will be conveyed to our speakers as you will be asking on the chat box. Thank you so much. Moving to our next speaker on board. And next speaker, we have Mr. Raman Lamba, Executive Director, Macabre BK Private Limited. Working with Macabre BK Private Limited for last 34 years in the capacity of Executive Director, having total experience of 36 years dealing with marketing, business development, and project execution on turnkey basis, operation and maintenance, spares and services for ash handling system. He has been associated with almost all aspects of coal-based thermal power plant businesses, especially in ash handling systems, coal handling systems, and other associated latest technologies in the field of ash handling systems. He has also played a key role in accelerating the growth of Macabre BK Private Limited as India's most efficient company in ash handling systems in power industrial all around the world. And Mr. Raman Lamba, Executive Director, Macabre BK Private Limited. Over to you, sir.
Good morning, everybody. Can you hear me, sir?
Yes, sir. Yes, sir. You are audible, sir.
Good morning, and I will share you a small PowerPoint presentation about what all about our company. We do all type of ash handling system. And after the presentation, all discussion on the latest development, we will discuss on the discussion forum. So this is the view from our office. I am only showing you about our company. We have our corporate operation office. We are operating from Noida. This about the view about our manufacturing units. We basically Macabre BK is a 100-year-old company, and we started with the civil works, and then finally in 1980s, 86 we have started ash handling system. Earlier we started with the civil works, and this Chakki bridge, which connects Jammu and Kashmir and Pathankot, is constructed by our group BSBK company. The ash handling system we established in 1986-85. Then a joint venture company was formed, the name of Macabre BK, with a collaboration from Clyde Bergman, and that joint venture exists up to 2015. Now 100% shares of Clyde Bergman is purchased by Macabre BK, and we are doing 100% Indian indigenized company. We have done 1,800 ash handling plant in India, right from 10 megawatt to 1,000 megawatt. 1,000 megawatt we did the ash handling plant outside India in Indonesia and Malaysia. manufacturing unit view, sir, and the office view. As I already said, we do all type of ash handling, high concentration, lean, pneumatic, and we do coal handling and alumina red mud handling system. The pictures of site location. We do coal handling, sir, bottom ash handling, fly ash handling, ash slurry disposal system, coal eject, material handling, pneumatic conveying system, red mud, operation maintenance, and we do operation maintenance as well. And these are our product, but we do all type of vessel, special wall, dome type wall, then variety of ash conveying vessel for conveying from smaller distance, longer distance. We have a capability to convey dry fly ash directly from the ESP up to a distance of even 2.1 kilometer. We have done. We have the capability to do it up to 3 kilometers. This is all about our system. We do coal handling also. We have started and we are doing coal handling plant for NTPC project today. We did 2 into 500 Kothagoda, Meenakshi Energies. But all the critical equipment like crusher screens, we source it from OEM. This is about the bottom ash handling system. Submerged capture chain conveyor. This is with the dry bottom ash hopper. Bottom ash is being conveyed up to the silo. Then we have jet pump system, water imported bottom ash hopper, jet pump system. Then closed loop, zero discharge. We take it the bottom ash slurry to the bin and then water is being recirculated. Then we also have done mechanical dry bottom ash type ash handling system with the support from Clyde Bergman. We manufactured this dry bottom ash conveyor with their support for 3 projects in India. Then about the fly ash handling system, we have done vacuum extraction, vacuum type extraction system, then vacuum positive pressure density pneumatic conveying system. Then old days we were doing hydrosilicic type slurry making system by means of feeder ejector flushing operator system. Then this, the latest concept I can say nowadays is the high concentration slurry disposal system. We did number of projects in India for NTPC and all state electricity board with a concentration level of up to 65 to 70%, and even the pumping distance up to 16 kilometers. We invented coal mill eject handling system also to handle the coal eject after milling and take it to the bunker for truck disposal and its utilization. And we have supplied almost all the NTPC projects. So about the material handling, what we are doing. Beside this, we have done shallow unloading system, open truck, enclosed tanker. We have done wagon unloading system, and even we have done barge loading system that not in India, but we did in outside India. Then we did one plant in classification for Lafarge cement. Red mud, we did paste pumping, red mud, this after the refinery alumina waste. That is the paste pumping system we did for Vedanta. This is about the pneumatic conveying system. For various bulk order, we have the pneumatic conveying system. Besides that, we do operation maintenance of the plant. We are, as on today, we are doing on 18 project operation maintenance for various state electricity board, and we were doing for few NTPC project as well. And after sales service, we are providing all spares to meet the requirement after operation, during operation for smooth operation of the plants. It's about the product, what we are doing is DenseSphere. DenseSphere is a totally enclosed system, and that too is being used for conveying fly ash from ESP hopper and various hopper for short distance. Then we have another ash vessel. It is a multi-connection system. All 4 vessels can be fired from the ESP hopper, and that too has the capability to handle up to 400-500 meters. Then we have MD pump, capability to deliver up to 1 kilometer. Then D pump, we go even up to 3 kilometers. Yes, we have supplied up to 2.1 kilometers. Then open truck unloading system, ash conditioner, pug wheel you can say. Then we have motorized unloading system. This dome wall is a unique, special designed wall for the ash handling system, and we use for all application for isolation, conversion, diversion, shallow time transfer application. And we manufacture up to half a meter size. It has so much plus point, and I think it has been installed in various plants. You might be aware about all these features. About our credentials, we got the national award for utilization of dry fly ash equipment supplied for this. Then about our health and policy, we are ISO 9001, 14001. These are some performance certificates issued by our valued customers. This about the promoter of group. Our chairman is Mr. Ajay Kumar Gupta, and joint managing director Mr. Ajay Gautam Gupta and Karan Gupta, and Mr. Rohit Gupta is our technical director. All working from the. Then Mr. Jitendra Gupta is director of finance. This is our corporate office view, inside view of our manufacturing units. Financial turnover above our company for 2017, 2008, 17-18. We have supplied ash handling system worldwide. This is the view of what we supplied to various countries: Indonesia, Malaysia, Philippines, Vietnam. About the walls, I can show you small animation. The beauty of this wall is that it's a full bore opening. It's have a perfect sealing arrangement. It can cut through the material to static column. It's never come in the material part when during opening, closing. This is about animation of one of the single point vertical system. This is for handling fly ash from multiple points from the ESP hopper. Then same for long distance and conveying kilometer. Sorry. see concept. So we manufacture smart scalpel chain conveyor for bottom ash handling system. And recently we have supplied for 1000 megawatt plant in Indonesia. It's fully automatic. It has automatic chain tensioning arrangement, hydraulic motor, and it has motorized base. You can follow the conveyor for maintenance. It's discharge and passing through the crusher. Is pulling out the conveyor for maintenance. Next, I'm showing you motorized unloading sport for unloading of fly ash, tanker unloading. This is basically a tanker unloading system. These are installation about fly ash handling system. This is about the various type of method of conveying lean phase, dense phase. The utilization of dry fly ash for treatment, crushing, and cement, that too the ore system is being adopted. Thanks. That's all about the presentation, and
Thank you so much, sir. Thank you so much. That was Mr. Raman Lamba, Executive Director, Macrobird BK Private Limited. Thank you so much for your lovely presentation, sir. Well, people, we are seeing that we are having some questions from this seminar. In this seminar, we're having some questions, and many people are watching on YouTube also. We're getting some questions from YouTube also. So I'll be asking some questions to our speakers here, our dignitaries here. And next, we are going to have in our panel Dr. Ss Malik. Dr. Ss Malik is the Associate Professor and Faculty in charge of Powder Flow Laboratory of the Department of Mechanical Engineering, Thapa Institute of Engineering and Technology. And in this capacity, he is been the principal investigator for several design, research and troubleshooting projects for NTPC, OPGC, HPGC, Reliance, Aditya Birla Group, etc. He is also the director of Bulk Solids Innovation India Private Limited. After a brief stay in the manufacturing industry, he served development consultant Private Limited DCPL for 5 years as a design engineer providing consultancy services to thermal power plants. Dr. Malik specializes in pneumatic conveying powder characterization and flow properties. He is also the associate editor of an international journal, Particulate Science and Technology, Taylor and Francis. Over to Dr. Ss Malik for the presentation. Thank you so much, sir.
Thank you so much. I just wanted to make sure that my screen is visible. So could you please?
Yes, sir. It's visible. It's properly
visible, and my voice is audible, right?
Yes, sir. Absolutely, sir.
All right. So I'm Dr. Ss Malik, and I formally welcome all of you to this session. And to start with, I thank all members of the organizers. I know how hard this is to work these days in coordination. And so thank you for your efforts in putting us all together this morning. And I welcome all the delegates once again. And without much further introduction, let's see the agenda for today. What we are going to do today is we are going to talk about some of the latest research and development which has come, and how that is extremely important in designing plants and troubleshooting plants. Now, it is challenging fly ash handling systems for various reasons, and I will go through those reasons. So if some systems are not working properly, there are reasons for that. Let's see those reasons, and then let's try to find out what are the solutions. Now, I just wanted to quote, I once read a book by a very famous professor, Professor Wang, and he said, it's easier to go to Moon or Mars than modeling and understanding what's going on in a powder conveying system, especially in dense space systems or dense space fluidized beds. So if some certain things are not working properly, I think we can accommodate that, but then we also have to find a solution for those. All right. So that also shows or highlights the importance of research and development in this field because of the complex interactions which happen between the powders, and there are millions and billions of those powders when we are dealing with fine powders. Right, so agenda for today is why the pneumatic conveying systems in fly ash many times do not work. What are the hidden issues? What are the design challenges? Is my airflow correct? Very, very important parameter, airflow, but there are several other stuffs that we are going to see today. But is my flow correct? Then we are going to look into the blow tank aeration issues. This is a very important issue. People always, many times people don't pay attention to it. And finally, some hopper bottleneck issues. All right, so for I'm being the last speaker in this panel, I may not have time to address all the chat box questions, but you are welcome to connect to me in my email, which is ssmalik@thapar.edu. All right, so a very brief introduction about ourselves. Excuse me. We started as a research team. Of course, being university research, teaching and research becomes our topmost priority. And my PhD was on bulk material handling, pneumatic conveying, so it's quite natural that I got sucked into this area. So over a period of time, we developed, we increased our strengths. So we have developed a pneumatic ash conveying test rigs, then powder spreadability testing that we do. Okay, let's go to the facility. So pneumatic dense space ash conveying pilot plant we have at the university. We also have vacuum conveying pilot plant. Now this is very, very unique, I tell you. Not many universities, they have vacuum conveying pilot plants, and we convey in large numbers. Let me also tell you, fluidization deaeration chamber, then we have powder flow tester, then hopper rigs, then we have powder characterization equipments, All right. Then we have powder spreadability. Then we have now we are into DEM simulation. So we are simulating the powder flow or particle flow. All right. So some of the recent projects, pneumatic conveying is something which is very close to my heart, but we do also work in certain other emerging areas of powder technologies. All right, so I'll show you what we have in our lab, but for the moment, let's show just demonstrate a transformation. So we started as an institute lab, but then with the national policy which came out last year for MHRD, Government of India, asking universities to bring their innovation to practical for the benefit to industry. We did our research, and we did lab scale research, then we did industry validation, and then we have now opened a startup company, which is a technology-based company. Over a period of time, let us also acknowledge our sponsors. NTPC has been our major sponsor. We have done quite a lot of work with them. I have personally conveyed about 20 to 25 ash samples from various power stations through NTPC, and in both pressure and vacuum systems. We have also worked with some other industries, but I don't have time to explain all those things in detail now. In our company, basically, we are looking into troubleshooting, design and troubleshooting. That's what we are trying to do. And our strength is research and innovation. Because we are placed at the university, so that we have the ecosystem going for us. So we do design, we do troubleshooting, and also we do EPCM. All right, and there are various reasons why a pneumatic conveying system may not work, and we go about this like a medical doctor, finding one reason at a time, eliminate needs, eliminate causes, and then we get to the bottom of it. So I'm one of the founder of this company. Then we have Professor Peter Wipich, who was my PhD supervisor. He's very reputed all over the world. He has done about 800 projects in material handling. Over 50 are in ash systems. Then we have our second director, Mr. Deepta Sundar Malik. And Mr. Malik has been the executive director and head of mechanical engineering department of development consultants, DCPL, and has been also the GM of general manager of DCIPS. And he has over 45 years of experience in power sector, designing and doing EPCM. So he looks after all the EPCM business of our company. Then two of my colleagues, Dr. Atul Sharma and Dr. Kundal Lal, they used to be my PhD students, and they have done quite a lot of job over a period of last 10 years. And now we have them as regular faculty, faculty at our university as Thapar University. So we are university-based company. I work as a professor at Thapar University Department of Mechanical Engineering. Now this is our pneumatic conveying test rig. This is our new rig. This is our vacuum conveying system, and this is our pressure conveying system. In our rig, we have conveyed 60 ton of ash per hour in pressure and 30 tons per hour in vacuum. So what it does is, when you convey such high capacity ash, it gives you very good quality data, and it makes things a lot easier for you to model and scale up. So you do very accurate design when you have such high capacity conveying facility. 60 tons per hour, 30 tons per hour, these are big numbers for universities within the institutes, but we have achieved those thanks to NTPC. NTPC has been the main supporter for us over some years now. We also have powder characterization lab, some very sophisticated equipment we have got from Belgium. So they look into some spreadability issues, the flowability issues, angle of repose, etc. So we can do a lot of testing, both at a macro scale as well as at a micro scale. Now let's go into some. Let's go and see what's happening at the plant. Now, very briefly, what's the plant requirement? What do you want as a customer? There are some vacuum systems which are working at some vacuum streams working, let us say, just an example, at 60 tons per hour, 60 tons per hour. And then you have your buffer hopper. And then from here, you take straight down to the remote silo. Now, this length could be anything, 500 meter, 1.5 kilometer, 1 kilometer, and so on. And I mean, this is basically what's your requirement. Now, what are the common problems that you have? Is everything okay? No, there are sometimes you face some problems. And you know, when there is a problem, you ask the customer, what's your problem? What's the broad statement? What's the problem statement? And he would invariably say, you know, we are not able to convey enough ash, under capacity, sometimes the line blocks, and my ESP hopper is going up and up. So these are the broad problem statements that he's going to talk about. And if you ask people that, what do you think about the reasons? And people who generally say, okay, it's not working, you know, maybe the compressor is small, or maybe the vacuum pump is small, or maybe the pipe diameter is small. So we know the broad problem statements, and we also know what people think about it. So they say about these three things: small compressor, small vacuum pump, small diameter. Now, is it all that's causing you the problem? And my answer is no. There are 15 plus reasons why your pneumatic conveying system may not work. And let me just read out those reasons. You might have an undersized compressor, smaller undersized vacuum pump, small pipe size, wrong selection of the location of step up. Maybe the blow tank is small. Maybe you don't have adequate airflow control in the blow tank. That's very, very important. Maybe you are not maintaining the enough DP across the blow tank. Maybe your fluidizing pads are not working properly. Maybe you didn't select them properly. Your feeder surface finish, very important. I'll show you some pictures. People often don't pay attention to these things. Material handling valves, I think some of my previous panelists have also discussed about this. Then the flow through adapter piece, the ash can get cool, and as soon as it gets cold, the flowability decreases. Maybe the hopper is not properly fluidized. The question of conveying ash only comes if the ash comes in the line. If it doesn't fall from the hopper, what are you going to convey? Improper ash intake valve setting, then maybe your back filter is undersized, some operational control issues, and maybe some pipe layout issues. So there are over 16 reasons that I could straight away write. And the thing is, if any of these reasons, these issues are there, you will be in trouble. And so there is not 3 issues or 2 issues or 4 issues, there are many issues. And as an investigator, what we do is, by the way, we call ourselves an investigator. So what we do is we go about and find these out, just like a doctor. You know, a complex disease, we just go and make checks. We don't make assumptions. We check, we test, and then we find out the disease, find out the root cause, and then we prescribe the medicine. We don't go by the rule of thumb. We do a proper analysis, and based on years of research and understanding of what's going on at the powder level. All right. So let's see, why do designs fail for the first in the first place? I mean, why should it fail? I mean, there are a lot of things which work. Why my ash handling system is not working? That's because you are dealing with a product which vary quite a lot in terms of properties. If I just talk about broad properties, the particle density can vary from 1600 to 2400 kg per meter cube, just some numbers. Loose port bulk density can vary. In fact, they can vary up to even 1000. I've done that. 600 to 900, very roughly. Your particle median size can vary from 60 to 180. So you have a large variation of your input parameters, and you are asking someone to design it properly when you don't know what's the ash property. So you design something for a 80 micron ash or a 90 micron ash, and you get an ash which is 140 micron. I'm talking about fast filled ash, the median size, and you will be in trouble straight away. You design something for some bulk density, the bulk density increases by a factor of say 30%, you will be in trouble. So there are a lot of issues, so it's not easy. We accept that. Now these are broad issues, but also there are other issues, more finer issues. The particle shape is important, cohesion, particle shape, cohesion, particle size distribution. It's not just one size, guys. It's about the distribution, how much fines you have, fluidization, deaeration characteristics, does it flat the line, and conveyability overall. Is it a dense phase material, dilute phase material, medium phase? So all those things are very, very important. some challenges. I mean, if I just pick up some very simple stuff, bulk density, we talk about bulk density, but what bulk density are we talking about? There can be 5 different bulk densities: loose poured, aerated, tapped, fluidized, compressed. You tap your powder, the density is going to change by 50% just by tapping, especially if it is a cohesive powder, if it is a fine powder. All right, so these things can happen. The other problem is particle size. It's very difficult to get repetitive values of particle size. The problem is, you know, you have tons and tons of ash sitting in your ESP hopper, and then you take a few grams of sample out of it, okay, first kgs and then grams and then milligrams, and you do a laser diffraction testing to get the particle size properly. First, by the way, you should do laser diffraction. If the size is below 80 micron, your sieve is not going to work properly because of the electrostatic charges. Now the problem is, from tons you have come to milligrams. So how do you know that the stuff you have got, is it the right sample? Maybe when you took the sample there was segregation in the hopper, right? So so repetition, it's very hard to get repetitive values, right? So sometimes people talk about what's the particle size. I mean, what size are you talking about? When you take a sample at 11 a.m. and you take a sample at 10 a.m. and you take a sample at midnight, everything is different, just because of the way you have sampled. So it's not an easy task, we understand, and you need to have a technology based approach, not a thumb rule based approach. All right. Because of the lack of time, I can't touch all the issues, but some issues that I'm going to talk about. Pressure system. Now, when you what we do is we have seen that when you increase your pipe diameter, your blockage, you need extra airflow. Now, blockage is a very critical issue. If the system blocks fine powder, it bangs, it blocks, and it's very hard to remove it, right? So we don't want blockage. I mean, that gives us nightmares, isn't it? Now, how can I overcome blockage? So you have to give enough air. Now, what's enough air? Now, sometimes people say we design based on air velocity, but I personally don't like air velocity alone. We also increase pipe diameter, because we have seen through many experiments that when your pipe diameter increases, your air velocity, you need extra air velocity. So we use a Froude number based criteria. Depending on the type of powder, your Froude number will vary from 4 to 6. Of course, you have to put certain margins on that. You don't operate on blockages, you put certain margins, and excuse me, and yeah, you get the right airflow. So over a period of time, you know, we have also worked with the pressure drop, predicting pressure drop correctly, and our models have been independently verified by people from other countries, and they have found it very common. So what we do is we consider there is a dense phase layer at the bottom, and then there is a dilute phase flow which is happening. That's basically your medium phase. So we model these two phases separately. Now I'm going to come to some very interesting points. Just let me have a little sip of tea. Now I'm going to come to a very interesting point here. In India, we think that the more we give, the merrier it is. You know, your gym instructor says, do these 30 minutes, and you end up running for 1 hour, and then you are gone. So we think the more the merrier. It's not always true. Let us say this is, let's look into this diagram. This is, we call the pneumatic conveying characteristics. In the Y, I have y-axis pressure drop. In the x-axis, I have mass flow rate of air. And these are some characteristic curves. These are like simply HQ curves for pumps. Now, the more tonnage you have, the higher is the pressure drop line. All right, let us say this is the point where you should operate. Let us say just a random point. This is the point where you should operate. Now, what you have done is, so this is your 120 ton per hour line. So let me write this. This is, excuse me, this is a 120 tons per hour line. And this is the line which corresponds to 120. And typically, this is where you operate in the plant. You don't work here, which is a blockage. You don't work here, which is a dilute. So you kind of work at the medium phase zone. Now, what you do is you say, oh, let's put margin. Let's put extra margin. The problem is when you put extra margin, the extra velocity that you give, the extra air that you supply, that eats away much of the available pressure. Okay, because your total line pressure is a summation of air only pressure plus the pressure drop due to the solids. All right. Now what happens? Let's see. Now you are supposed to be working here, and then you give extra air for the same pressure, because your compressor has a certain maximum pressure minus all those air dryer pressure and blah blah blah. And then you have so what you do is this point now shifts to this point. Okay, so let me just clear it. So you are supposed to be operating here, and you have said, you have thought the more the merrier. So you are now operating here. The problem is when you come from this line to this point, now this point is not 120 ton per hour anymore. So this is something between 100 and 120. So probably you are operating at 110 ton per hour. And that's the critical thing, and that's why the design is so critical. It's not one way. You have an upper limit, you have a lower limit. You have to give enough air so that you have a reliable conveying, but don't give too much air. Of course you end up purchasing a bigger compressor, but not only that, you may reduce your tonnage. The other is more straightforward. When you don't have enough pressure, simply you are supposed to operate here. You don't have enough pressure, so you end up operating here, which is from 120 you come down to 100 ton per hour, because you don't have enough pressure. Why I'm saying this, although this is very apparent, that's because people many times they talk of only airflow. Wow, how big the compressor, what's the airflow, 7,400, 8,400, 6,000, blah blah blah. You also have to look into the pressure. If the pressure is not there, you won't be able to transport the ash in the right tonnages. You may be able to overcome the blockage, but you won't get the tonnage. So you have to look into your tonnage, pressure, as well as you have to look into your airflow. Something very interesting for the vacuum system, which can get really sensitive, I tell you, really sensitive. This is a characteristic curve for a vacuum system, and this is my capacity in terms of meter cube per hour, and this is my vacuum. Now this is at the suction condition of the vacuum pump. All right, suction condition. Now let us say you want to ideally work at this point. So what's this point? This point is, say, let us say 350 millimeters of mercury vacuum. Now let's say what's happening is you have started to get a little blockage in the line. So your vacuum is going to shoot up. Now let's say from 350 your vacuum has got from here, it has come to here, right? So what's the now this is the characteristic curve for the vacuum pump. So what you have to do is you have to walk through this curve, and then you come at this point. Now you come at this point, originally you were at this point. All right, so you come here and you might think, oh look, if my vacuum increases, this is so nice, isn't it? My flow actually increases. So it goes, say, from this to it goes you get an increase in flow. Now the problem is, yes, you do get an increase in flow, but that's in volumetric flow. When you multiply that by the air density, your mass flow rate from 0.67, just a rough exercise, is a fictitious issue. Don't take reference of a particular plant. This is not in the reference of that, but just as an example, your mass flow rate actually goes down. And please remember that your air mass flow rate is very, very important. All right, so it's not just the vacuum flow rate, but also the mass flow rate. That's very important. So your so what happens is you actually lose your mass flow rate because of the rapid loss of air density under high vacuum. All right, and one thing you have to remember, that in vacuum, what I call is, I love to use this particular sentence, and that it's self-forgiving. The vacuum system is self-forgiving. It doesn't choke all of a sudden. It pulls. But the thing is, you then open your shutoff valve, your material discharge valve closes, and then again your line vacuum has to pick up. So it takes time. So, and time is tonnage in pneumatic conveying. And another very important issue is your blow tank aeration. You have to put the right type of aeration pad. You have to put them in the right place. In our lab we use stainless steel sintered pads. and they give you the right kind of air permeability. So what happens is when the air comes out nicely, this entire surface, so this entire surface over here, this becomes friction, less friction. I won't say frictionless, but less friction. So the ash can actually flow nicely. Also, the air that enters, it comes out. It has to come out from somewhere, and on that way, it drags certain particles into along with it. And I tell you, a little change in fluidization air, a little better quality of pad, little change in fluidization air doesn't seem to be a very big thing, but it makes huge difference in your tonnages. I mean, we have got many experimental data to support that. So this is certainly not an issue that you should ignore. Another very important point is you have to create a pressure differential across your blow tank. If you don't do that, the ash is not going to come out. You have to remember, this is not an easy path for the air to come in. Air always wants to take the least resistance path, which is the conveying air. Now, if air doesn't come as a top air or as a fluidization air, I mean, it has to push. It has to come in the blow tank to push the material out. If it doesn't happen, material is not going to come. So airflow control is so much important. You have to give the right DP, but don't give very high DP, where then you would actually lose a lot of pressure. So this is what happens when your airflow control is not right. So this is a top discharge valve, and you can see that at the center part there is some you can see this has got a slope. So that means that this is all full of ash in a certain blow tank in some project. That's because from the side the air really didn't come out properly, and so the ash didn't come out properly, right? So ash has got agglomerated, so you can see the entire pad is choked, and of course maintenance of these pads become a very critical issue. Now, so one of my speaker was talking about rat hole. Rat hole is one problem, arcing is another problem. I'll show you a picture of rat hole, and this is arcing. When you have very fine ash and it becomes cold and there's a moisture and it sits over there, gets compressed, and you start to get arcing. All right. So you have to apply the right aeration again, but again, that's not very easy. Some small issues, how they can be big bottlenecks. So this is inside an ESP hopper. Now you can see these corners. These corners are the first starting points of ash agglomeration. Sorry, not agglomeration, ash buildup. Right. So you can see that the ash is getting built up. You can see from here, right? And you can see that this opening, which is originally like this, is actually getting smaller and smaller. And then eventually you get this all blocked up. Okay. So just okay. Now what you have to make sure that when you take any surface, the surface must be smooth as much as possible. And so I came across this blow tank somewhere, and you can see that it's actually not it's not a bent structure. It's actually there are plates, and those plates have been joined. And now you know from the last picture that when you join plates, what's going to happen. So you can clearly see the joining marks. And I have seen blow tanks where even inside you have joining marks. So surface finish is very important in the blow tanks. Now you won't believe it. This is actually an ESP hopper. And I have a very acrobatic colleague actually who went inside the ESP hopper, not in operating condition, of course, but he's very tall, so his hands are very tall. So he just put his camera in, and he took this picture. Now this looks like a hopper, isn't it? A perfect hopper. Certainly not. So this is rat hole. You have rat hole happening, right? So when this happens, what happens to the surface? The surface becomes extremely rough, and when it becomes extremely rough, you have more and more friction. So your capacity reduces, and you start to get ash built up. And you are blaming your vacuum pump, and you're blaming your compressor, but maybe it's just ash is not coming out. So this is one of those 15 reasons. Just hang on a sec. All right. So I come to conclusion. I think I have stuck to the time. So conclusion to conclude is understanding very important in modeling and scale-up procedure. What's happening at the particle level, bulk level, that's very important. You must be knowing the fundamentals. I would strongly recommend you don't see the system and the components in isolation. Many times people pay attention to the system and they don't pay attention to the component, and vice versa. They go hand in hand. I tell my students this dialogue that your blood has to be fine, which is the system, but your heart also has to be good. The fibers of your heart also has to be good. Now that's the component. They both have to go hand in hand, and you have to systematically we need to do is we need a systematic diagnosis of the root cause. Root cause analysis is so much important. If you want to collaborate with us in academic and research issues, please write an email to me in ssmalik@thapar.edu. If you want to do a research project, that's the way to go. But if you want to do a design or troubleshooting work with us, then you write to my other email address, which is director@bulksolidsindia.com. All right. So with this, I thank all of you, and I once again thank the organizer. And what we need to do is we need to make a cleaner earth, and so that our children can live long, and they make the earth even more beautiful. So with that, I stop here, and I thank all of you again for your for your attention, and I thank the organizers again. Thank you very much.
Thank you so much, sir. That was Dr. Ss Malik, Associate Professor, Thapa Institute of Engineering and Technology. Thank you so much for your lovely presentation. Well, people, as I said earlier, that we have got our respective speakers with us here on board. And if you have any questions regarding the presentation, or if you want to shoot any question to our honorable speakers here, you can ask in the chat option button here on Zoom, or some people are watching on YouTube, and we have got some questions on YouTube also. Dr. Abhishek Goel is super active, and he has also given the answers on the YouTube and on Zoom. But some people might not be watching on YouTube. So again, I want to deliver the question here on this platform, and it's for Dr. Abhishek Goel here. And sir, it will be kind enough if you can answer here on this platform verbally. Well, it's online Fg duct level measurement is mentioned. How in unit running condition it can be cleaned during overhauling time, ash accumulation profile can be mapped. How I clean in a running unit. It's to Dr. Abhishek Goel. It's from engineer Dipankar Shingupta.
Yes, sir. So thank you very much, sir. So actually, in FG duct, it is more important to know the level rather than cleaning first. So what happens is, if your plant is running and if you have a level measurement installed with a 3D profile, you will know if the level has accumulated beyond a critical point or if there is an uneven collection. In either cases, you will have to stop the boiler, take a shutdown, and do the maintenance. Whereas if you don't have a system which tells you what is happening inside a FG duct, and if the critical points reach, there may be a collapse of the FG duct, sagging, and a fatal accident. So using measurement, you can know the point of fatal accident and avoid that by doing a shutdown and maintenance. So during operation, there is no requirement of maintenance, but you need to know the point when the maintenance is required. And I think my dad okay, yeah. So this is what is basically for the FG duct, why measurement is important and maintenance comes afterwards.
Thank you so much. Thank you so much, Dr. Goel. This is another question for Dr. Ss Malik. It's a question from Shopon Mondol. He wants to ask a question to Dr. Ss Malik. What material composition will be used in ESP hopper or buffer hopper liner? It's a question for you, sir, Dr. Ss Malik. Yes, sir.
Yeah.
Dr. Ss Malik, this is a question for you.
Yeah. Can you hear me now?
Yes, I can hear you. What material composition will be used in ESP hopper or buffer hopper lineup?
Look, first of all, the if you have if you look at your ESP hoppers, they actually are designed with a steep slope. Okay. So first of all, the if you are not compacting it, and if you are not having a very cold condition happening, your ash should able to flow. But in general, you should use stainless steel if that is for both these hoppers. But then you also have to put it in the right place. You don't you put it in the place where you have the maximum chance of creating arcing. What you have to make sure, that there is no dead zone in the hoppers. Okay. Say for example, if you have a hopper, I would actually put more stress on the fluidization. The ash is hot, we know, but sometimes you do have these dead zones, and also the eccentric flow that you have sometimes.
Uh, Dr. Malik, I think you are in a mute mode.
I have unmuted myself.
Yeah. Now it's unmuted.
Yeah.
Yeah. There's another question for you, sir. It's from Sanjeev Bera. It's for you, Dr. Malik. Two compressors have to run at a time for conveying. What is the reason behind?
Now, that is how you have selected your compressor. I mean, if for one line, if you have one compressor sufficient, then you run one compressor. So could you please explain the query again? See, it is about how, see, for every line you need certain amount of airflow. Okay. So you have one line and there will be a certain tonnage, and for that you calculate your airflow. All right. So if one compressor can satisfy that, then you run that compressor only. Of course,
Okay.
just a moment. I am assuming that you are doing your fluidization from that compressor only. So you are not having a very high DP, high differential pressure type fluidization pad, and for that you use a different compressor. I hope that's not the case. So you should ideally have one compressor, or if one compressor can give you enough airflow for one line, then you use one compressor. It's all about matching the available compressor size to your airflow requirement.
Thank you so much, sir. I think Sanjeev Bera is satisfied with the answer. Moving to our next question, goes to you, sir. Dr. Malik, this is for you only. What will be the temperature of the fly ash hoppers? It's the question from Arijit Dev.
Temperature of fly ash
Hoppers.
No, I'm not getting it. Fly. I mean, is he asking about the hopper wall or the fluidization air temperature? If it is fluidization air temperature, honestly, that level of research, exactly that that if it is 70 degree, 80 degree, 60 degree, if you do that, then how much actually how that extra temperature is percolated, in terms of your increasing tonnage, that research has not been done. So I can't give you the exact right temperature which should work for you. But definitely, you should have you should ensure that the ash doesn't get cooled down. right? And so yeah, I mean, I can't give you the exact number, but yeah, the whole idea is the moisture shouldn't be there, the ash should remain fluidic.
Thank you so much. That was a question from Arijit Dev. I think he's satisfied with the answer. There's another question for you, sir. That's question from Shomala Goswami to Dr. Malik. Sir, do you work or investigate for uneven flow distribution? What do you do?
Could you please repeat? In between, there was a connection issue. Do you work?
Do you work or investigate for uneven flow distribution?
Through what? Through buffer hopper, I guess. I guess that's what is meaning. Yes. Yes, we investigate that.
I think he's asking buffer hopper.
Yes. We investigate that. Yes, we do that. We actually have buffer hopper rigs also in our lab. So, and that rig is little flexible. So what we do is, if you have a particular type of buffer hopper, we do certain arrangement. It takes a little time to do that, by the way. And we replicate your buffer hopper inside our lab. Then we put the ash there. And then we put all those cameras and all those things, and we see that what's happening, whether this is building up on certain areas or not. And then what we do is we have this little arrangements, so we give air here, then we give air there, and then we see that what's the best arrangement of air injection location and the amount of air. So we vary that air also. So that way we investigate this, because this is, see, I tell you something, if you look into the if you look into the theory of hopper flow, that is applicable for symmetric hoppers. Okay, so the theory of flow is applicable for symmetric hopper. So we have powder flow tester. Using that, we can actually tell you that what should be the opening size of your hopper, what should be the slopes, but that's applicable for symmetric hoppers. If you have a non-symmetric hopper, we apply certain factors to it, and then we validate by making an arrangement in our laboratory. Right. So yes, we investigate analytically, and also we investigate experimentally, and we can find the root cause, and we can find the solution, where you need to give the air, how much air you need to give.
Thank you so much, sir. There's another question for you, Dr. Malik. What is the effect of trace material in coal on the ESP performance? And we have got line questions from Shovik Mondal also. Does the trace material like alumina, silica, iron escape through chimney? Usually this not catched by bag hoppers. Then what is the remedy?
Thank you for the question. Unfortunately, this is not into my area of expertise. So I would not comment on that, because I don't want to give a wrong answer.
Okay, so Mr. Shovik Mondal, if you can hear me, if you want to convey the question to a particular our speaker, so you can write the question again, or you can write whom you want to ask a question. There's another question. I think probably this will be the last question, I guess, because we are running behind the schedule. That's from Shomala Goswami. Okay, so it is for you. Uneven flow distribution through ESP passes. Uneven flue gas distribution through different ESP pass. That's the question he is asking. I don't know it's clear or not for you.
Yes. I think I know what he's trying to say. Let me assume his question and give an answer to that. I think what I assume is he's asking that what you said, a non-uniform flow through the passes.
Uneven flow distribution.
Yes.
Yeah.
I think what if I assume the question is that when that uneven flow distribution happens, how that affects the ash properties and the subsequent ash evacuation. So that's an assumption I make. That's the question. What happens is that let's say there is no uneven flow, first of all. Okay, so what happens is, even when everything is okay, what will happen that through the central passes, your ash particles, the bigger particles will actually come through the central ones, if I imagine that correctly, and the finer ones, they will go through the side ones. Okay, now that's my imagination. Now why that's an imagination, why I'm saying the word imagination, I will tell you later. Okay, first of all, listen to that, please. So what will happen in the center, you will probably get larger particle size than on the side. So you would when your vacuum system would work, because the particle size are larger, assuming the same bulk density, you will have longer time to evacuate those. Now let us also tell why I said imagine. We have not specifically taken a lot of sample specific research on this. We have taken samples, and we also have those samples at our lab. In fact, one of my student is now exactly doing this particular research. He is looking into the different passes and seeing and investigating the variation of it, and how and relating that, with the airflow and all those things. Now if you have a non-uniform distribution, of course your ash collection distribution, the property distribution would be also different. The way it goes from one field to another field, and the bigger particles will go in some area, the finers will go to some other area. So these things will be there. However, as I said, the vacuum system is self-forgiving, right? So what will happen is, in one pass you might take a little longer time, but in the other pass you will overcome that, because it really, unless and until it's really bad, it's not going to block the line. It will try to pull, and it will clear. So somewhere you lose, somewhere you gain. All right, so it's a complex issue. We are doing the investigation on this, and perhaps in another 2 to 3 months we will be able to tell you. But all we say is based on data and research.
Thank you so much, sir. Thank you so much, Dr. Ss Malik. That was the webinar. We were together with our honorable speakers, with our participants, and with our sponsors here. Latest technological advancement in ash handling plant of coal-fired thermal power station, organized by Engineers Welfare Forum, WBPDCL, SGTPP, powered by Enviro Level Controls Private Limited. Well, we had a great time. We had a great discussion here on this webinar. And to convey the thanks, we have got a very important person with us here in this moment. I would like to introduce Engineer Tarak Maji, Secretary, EWF SGTPP, here on board. Welcome, sir. I would like to request you to please say a few words.
Thank you, Kunal. Am I audible, visible?
Yes, sir. You are audible and visible both, sir. Thank you.
Okay. Myself, Engineer Tarak Maji, Secretary of Sagardighi Thermal Power Project, the biggest power plant of WPDCL in terms of capacity. So, good afternoon to every participant and experts joining together over this wonderful session of technical discussion. We had a fabulous session of knowledge sharing over a very important part of a coal-fired thermal power plant, which is ash handling plant. So ash handling plant has been always a challenging part of any thermal power plant, as environmental norms are getting very stringent over the last few years. So we decided with engineers Homendas, our General Secretary of EWF, WPDCL, to hear from expert in this field. EWF, WPDCL has been organizing webinars over last few months during this pandemic situation, and seminars over last 10 years over different technical issues and topics related to thermal power plants, and this is under banner of NEET, National Energy Excellence Drive. Now this is the time to customarily offer our sincere thanks to those who have actively or indirectly put their effort to make this webinar a grand success. First, our sincere thanks to our official sponsor, EIP Enviro Controls Private Limited, for extending their hands towards organizing this seminar. I offer my thanks to all other vendors on behalf of EWF who has financially helped us to organize such knowledgeable enriched webinar. We extend our thanks to Dr. Abhishek Goyal from EIC Level Controls Private Limited for his lecture and presentation. We have been enriched a lot from his content of speech. I offer my thanks to Mr. Rajat Goyal from Enviro Control Private Limited for his presentation over different aspects of ascending plant. We offer our special thanks to Mr. Raman Lamba, Executive Director, Macover BK Private Limited for his excellent deliberation on the important issues of ascending plants. We hopefully will implement his suggestions over our respective plants and will be benefited. I, on behalf of entire EWS family, offer my thanks to Dr. Ss Malik, Associate Professor, Thapar Institute of Engineering and Technology, for his detailed and specialized content on the topic, which I think connects research work and industrial issues together. It was wonderful. We also don't forget to offer our thanks to Shakti Digital and their fellow members for making this event very organizedly. Special thanks goes to EWS executive members, especially Mr. Somen Das and Sumon Sarkar Sahib, who tirelessly have been organizing such events. Last but not the least, our thanks to all engineers of WPDCL and other organizations and all other participants who have attended the webinar and make the event a grand success. Thanks to all and wish everybody stay healthy. And now it's over to Kunal for official conclusion of the webinar. Thanks.
Thank you so much, sir. That was Engineer Tarok Maji, Secretary EWF, WBPDCL, SGTPP. Thank you so much to all the dignitaries, our speakers, the spectators, and the members of Engineers Welfare Forum. And obviously, thanks to all the people, those who have showed their support to make this webinar a fruitful one. Hope that we'll be having a great time ahead. Maybe in this year or maybe the next year, we'll be seeing face to face and we'll be doing this live on stage, not on this digital platform. Hope you will be going great today and wish you a great day and wish you a great year ahead. Thank you so much.
In fact, we still see each other face to face.
Yeah, we'll be doing live. I think live will be more lively then.
Yeah.
Thank you so much, sir. Thank you so much, sir. Thank you so much, all.
Thank you.